Right, so here we are with system 3. As I said, we've skipped system 2. We're going to move on to system 3. System 3 is known as what we call mechanical extract ventilation. This is a continuous running system. Now there's two ways this system can be done. One is what we call a centralised unit, which will be a centralised fan. This is our MEV spider. And you'd run ducting from that fan to each wet room. Normally what we'd do is we'd run a series of ducts into individual ports on here. We can run up to maybe 2 into 1 port, like this picture shows, but if we had a utility on there and an ensuite, we'd run them into separate ports on the unit. So this unit's running all the time at a very low rate. It's drawing air up through a series of ducting, through the unit, and then off to atmosphere. Again, this could be through a gable end wall or through a roof tile vent, but it's running at a very low rate all the time. It's always doing is sort of sniffing for the air and creating that little bit of background ventilation. This particular unit is what we've got call a humidity tracker in it. So as the air's going through it, it will sense for the humidity. So if somebody starts having a shower or a bath, it'll actually increase its speed according to the relative humidity in the room. So if the humidity goes higher, the fan works harder. So that way it's extracting the moisture faster and off to outside. You can also have manual overrides where you could boost it for odour reasons if you wanted to. Or say if you've got a party going on in the kitchen, you just want to extract a bit more air. So as I said, this is extracting off to atmosphere. If we didn't want to use a centralised system like that, we could use some individual room fans. Again, I'll get my esteemed colleague to pass me one. So we've got one like this. This is our Eco DMEV. D stands for decentralised. So what we mean by that is we have individual room fans. So rather than a centralised unit, we'd have a decentralised fan, individual room fans, one in the kitchen, one in the bathroom. Because these are running all the time, they run on what we call a trickle rate. Approved document F, a technical handbook, would call it a whole dwelling ventilation rate, but for ease, we'll call it a trickle rate. That's a low rate all the time. Now it's doing enough. It's very low rate, doesn't use a lot of energy, doesn't create a lot of noise, but it's just drawing the air out gently all the time. And as it's doing that, if they've got a humidity sensor on there, they're sensing for the humidity, but it's creating a low level of ventilation within the dwelling because we're taking air out, we're drawing air in through natural leakage, or if it's a particularly airtight property, we may have a couple of trickle vents in there. Nowhere near as much as we use with System 1 when it comes to the background ventilation. The requirements are a lot less because we've got that more controlled ventilation. And what they'll do is when required, if somebody's cooking, showering, or even preparing fish for odour reasons, we can send these to a higher rate to get rid of that, the smells or the odours, and the moisture quite quickly. Again, off to atmosphere through the wall or up through the ceiling and ducted to outside. But the idea is we'll get rid of the moisture and any contaminants as quickly as possible. The flow rates on these, they do a trickle rate, they then go to a higher rate, which is what we call the boost rate. And again, within the approved documents and building regulations, they call that the whole dwelling extract ventilation rate. So it gets a little bit confusing, but for ease of things, trickle and boost. Trickle's a low rate, boost is a higher rate that they will go to. It's a much more, thank you very much, it's a much more beneficial and energy efficient way of ventilating. A lot of people have concerns because it's running all the time, you've got high energy consumption, you're losing a lot of heat out of the dwelling, but it's more controlled than your standard intermittent fans. So, and because you've got something running at a low rate, it's using less power. So they actually use less electricity, less power, and they don't extract as much heat as you want, because when they're on a low rate, it's a very low rate. It's a lot less than what the natural leakage would be in an old house. So it's more controlled and it's better for ventilation. Hence again why, when we look at this, for new builds, the Energy Saving Trust recognise it as best practice and good practice. It's an energy efficient way of ventilating a dwelling, a lot better than the traditional intermittent System 1 fans, especially when it comes to your background ventilation. You've not got all that air coming in, it's more controlled. So that's it for sort of System 3 really. If you understand, obviously remembering that we've got centralised systems or you can have decentralised ones. We'll now sort of finish off there and we'll move on to the next system, which will be System 4, mechanical ventilation with heat recovery.